From a charred pine log skimming a misty marsh to AI-guided megaships slicing oceans, boats have always stolen time from distance. Who built the first one? No name survives, only clues buried in peat. What secret upgrades mattered most? Sails, screws, or a simple painted line? Tonight, we'll time jump through reed bundles, Viking thunder, steam and steel, and wind's strange comeback, spinning cylinders and sky kites toward a future that feels surprisingly ancient and bold. No single name owns the first boat, but we do have the earliest survivor, the Peace Canoe, a hollowed Scots pine log dated to roughly 8040 to 7510 BCE and displayed at the Drents Museum in Assen, Netherlands. Found by a road crew near the village of Peace in 1955, it's just under 3 meters long, small, purposeful, and built for a watery, marsh-laced world. Radiocarbon dating and museum analyses make it the world's oldest known boat, a Mesolithic dugout likely shaped by controlled burning and scraping with stone or antler tools. Imagine the anonymous maker, no metals, only patience and embers, carving time and safety out of a tree to fish, ferry, and cross reed-choked channels. While later scholars debated whether it might have been a trough, comparative experiments and context support its seaworthiness and role as a working craft. In other words, our first inventor is an unnamed artisan, but our first creditable source is modern. The Drents Museum, whose records and display anchor the artifact in place and time. This is where the boat's story begins, not with a famous signature, but with proof you can point to, carbon-dated wood that still whispers of paddles on a still, brown lake. Reed and river craft, foundation. In the Fertile Crescent, builders lashed buoyant reed bundles and sealed them with bitumen to make light cargo boats that could survive long river runs. Archaeologists have traced such bitumen-coated reed vessels to the 4th-3rd millennia BCE. The principle was simple: a lot of trapped air, a waterproof skin, and a flat-form stable on calm rivers, perfect for everyday trade and fishing. Mediterranean oars and fighting speed. As commerce and war intensified, the Eastern Mediterranean perfected long, narrow galleys, the pentaconter, and then the trireme, optimized for human power. Multiple banks of oars delivered instant acceleration for ramming and maneuver, while light hulls let navies stage fast strikes and coastal patrols. Think of it as converting food into thrust at scale. Hundreds of synchronized rowers driving a planing hull across short tactical distances. Northern seaworthiness, the Viking longship. In rough northern waters, shipwrights overlapped planks or clinker construction to create strong yet flexible hulls that could ride heavy seas and, thanks to shallow draft, slip up rivers or onto beaches. Sail for reach, oars for control. A hybrid that made raids, trade, and exploration feasible from the North Atlantic to riverine interiors. Pointing higher, Lateen and fore and aft thinking. The introduction and spread of the triangular Lateen sail let mariners angle into the wind, not merely run before it. By mounting a long yard at an angle, the rig exploited aerodynamic lift. Combined with tacking, ships could choose courses more freely and work coastlines with new precision. A fundamental shift from pure downwind sailing. Workhorses of trade, cog, sternpost rudder, and the fluid. In medieval northern Europe, the single-masted cog added capacity and, crucially, a stern-mounted rudder that gave larger cargo hulls reliable steering in seas. Later, the Dutch fluid pushed efficiency further with big holds and small crews, dropping most armament to maximize ton miles at minimal cost. The operating logic? Standardized, cheap-to-run freight platforms. Independence from wind, steam, and paddles. In 1807, Robert Fulton's commercial steamboat proved a schedule-keeping river service. A Boulton and Watt engine drove side wheels to push a hull regardless of wind. Paddles are simple thrust discs, rotary motion scooping water aft, ideal for rivers and protected waters where fuel and maintenance were available. A better screw. Propellers replace paddles. In the 1830s to 40s, Francis Pettit Smith in Britain and John Ericsson, working in Britain and the US, turned the screw propeller into a practical ocean drive, a rotating helical surface that accelerates a column of water astern, converting torque into steady thrust with far less drag than side wheels in waves. This made steam broadly viable at sea. Turbines and the all-big gun reset. By the 1890s, Charles Parsons' Turbinia showed how a steam turbine's continuous rotary stages could deliver higher power to weight and smoother operation than piston engines. HMS Dreadnought, 1906, then put turbines into a capital ship, pairing speed with a standardized big gun battery and redefining naval design worldwide. Diesel at sea, cleaner, simpler power. The Danish MS Selandia, 1912, demonstrated an ocean-going motor ship burning diesel oil. Compression ignition pistons turned a crankshaft directly, eliminating boilers and allowing longer ranges with smaller crews. Great for commercial operators chasing reliability and fuel economy across global routes. Boxes that shrank the world. Containerization. On April 26, 1956, Malcolm McLean's converted tanker SS Ideal X carried 58 standardized containers from Newark to Houston, shifting loading from days to hours via cranes and intermodal handoffs. The how it works is deceptively simple. Put cargo in steel boxes sized for trucks and trains, move the box, not the contents, across modes with minimal handling loss. The Digital Watchkeeper, AIS, and the Networked Fleet. From the early 2000s under Solus 5, large vessels have carried AIS transceivers that broadcast identity, position, course, and speed over VHF to ships and shoreside stations. It's cooperative situational awareness, continuous machine-readable ship pings that feed collision avoidance, traffic services, and today's data-driven routing and fleet management. Today's toolkit, hybrids, foils, and wind assist, bridge to Section 4. Modern craft blend batteries with engines, lift hulls on hydrofoils to slash drag, and even bolt-on spinning rotor sails or kites to harvest free wind over blue water. The through line from reeds to rotors is constant. Better control of forces, buoyancy, thrust, and lift to turn vast distances into manageable schedules and sustainable costs. A painted line changed everything. In the 19th century, the Plimsoll load mark, just a set of rings and a bar on the hull, forced honest loading. Overnight, ship owners had a public, inspectable limit. Sailors stopped disappearing with "overloaded in heavy seas" as a line item. Regulation didn't slow progress, it made reliable schedules possible. Lemons beat the ocean. Long voyages once meant crews wasting away from scurvy. After shipboard experiments proved citrus prevented it, navies stocked fruit and juices. Healthy sailors could work rigging, fight storms, and complete expeditions. The real upgrade wasn't a new mast, it was a menu change. Worms versus empires. Wooden hulls rotted fast in warm waters thanks to shipworms. Copper sheathing, a thin metal skin, stopped the pests and cut weed drag, keeping hulls fast for months. The payoff was strategic: longer patrols, tighter blockades, and cargo that arrived on time. The box that shrank the planet. Containerization looked humble: steel rectangles, standardized sizes, but it rewired ports, rail, and trucking. Loading one from days to hours, theft and breakage cratered, and the just-in-time went global. The modern supply chain rides in a box. Wind's weird comeback. Today's tanker sprouts spinning rotor cylinders and giant automated kites. It sounds retro. It's data-driven thrift.
harvesting free wind to slash fuel burn and emissions. That surprise leads naturally to where boats are headed next.
Right now, the industry's headline is carbon. Ports are wiring up shore power so ships can plug in instead of idling. Operators are slow steaming to cut burn, and trade lanes are testing green corridors where low-emission fuels and practices are standard. The goal is practical: keep global schedules while shrinking the footprint. Electrification is winning the short hop. Battery electric ferries on commuter and island routes charge fast, run quiet, and slash maintenance. Hybrids extend that logic to workboats and coastal cargo. Electric for port maneuvers and low-speed transits, engines for open water. It's not flashy, but it's reliable, and reliability spreads. For longer legs, new fuels are the bet. Methanol is already sailing because it's easier to store. Ammonia and hydrogen promise zero carbon at the point of use, but demand new engines, safety systems, and port bunkering. Expect a messy middle where mixed fleets and dual-fuel engines are normal. The brains of the ship are changing too. Sensors, AIS data, and weather models feed route optimizers and digital twins that trim fuel day by day. Autonomy arrives from the inside out, first in ports and predictable coastal loops, then under human oversight at sea. Strangest and most familiar is wind's comeback. Rotor sails, rigid wings, and automated kites harvest free thrust, stacking with smarter routing and cleaner fuels. The future likely isn't one magic engine, but a toolkit. Electric where it fits, new fuels where they pencil out, and wind as the quiet multiplier tying it all together. From a charred pine log to a kite tugging a steel giant across open water, boats have always been humanity's quiet rebellion against distance. Each leap, reed bundles, latent lift, screw propellers, container boxes, digital routing, was really the same act, turning uncertainty into schedule, risk into range, and oceans into ordinary roads. Now we're standing on another threshold, where electrons, new fuels, algorithms, and wind all tug in the same direction. The surprise is how modern the oldest idea feels. If free wind can shave tons of fuel off a voyage, maybe the future is less about a single miracle engine and more about clever combinations that earn back time and clean the wake we leave. So what do you think carries us forward? Batteries, green molecules, smarter software, or the sky itself? And when we look back a century from now, which of today's experiments will seem inevitable? Which moment caught you off guard? The anonymous craftsman behind the Pessy canoe, the sudden power of the Lateen, the quiet revolution of the container box, or wind's high-tech return? I'd love to hear which era impressed you most and what evolution you want to journey through next. Submarines, lighthouses, canals, or the saga of the compass. If tech timelines and human problem-solving are your thing, there's a whole stack of stories waiting here. Settle in for another chapter when you're ready, and keep the conversation going below. Your ideas shape where we sail next.